Hello Algebra student, this video is for chapter 3.5 transformation of function. So we are learning how to graph a function by transformation instead of plotting points. By learning this technique, you can graph a lot of functions that are originate from the toolkit parent functions by transformation, and this is an important skill in calculus. Okay, so we'll separate it into two groups of transformation. One is shift transformation. That means you move your graph like just left and right, up and down. And sometimes it's called translation transformation. So what happens is if your new function is related to an old function, like our old function is f of x, suppose, and then your new function is f of x plus h, where h is a positive number, then your graph actually will shift to the left of f of x. This new function will shift to the left if you add h. And your x value, basically all the points in your x value decrease by h. If you have f of x minus h in your new function, then it is moving to the right for f of x. So compared to f of x minus h is moved to the right. So all the x value increase by h. What about if your number that you are adding, we call it k, is a positive number, it is outside of the function. So for example, you have a toolkit function of f of x squared, you just add 1 outside of it, then all of a sudden the new function f of x plus k is shift up and down. So if it's add, then it is up, if it's minus k, it is down. So all the points in the f of x plus k and f of x minus k will increase by k if it is adding, and it will be decreased by k if it's subtracting. Now notice when you are doing add inside for horizontal left and right shift, if you add a number, it actually decrease x actually decrease and you move to the left. Okay, it is the reverse. But when you do move up and down, it's not reverse. So plus k means up, minus k means down. So an example that we do is here. So we have a graph that we haven't learned before. It's not in one of the toolkit. It's a exponential function 2 to the x. So we graph it over here. We'll learn it in like chapter I think 5 or 6. I've forgotten. Okay, it's an exponential function. So we want to graph. So we have this graph, and I have it also graphed in the decimal. So we want to sketch a graph of 2 to the power x minus 3. So compared to 2 to the x and 2 to the x minus 3, you are replacing x by x minus 3. So if this is f of x, this g of x is actually f of x minus 3 inside, right? Because you're replacing the x by x minus 3 inside. Versus 2 to the x plus 3. So this is actually just the f of x, because that's 2 to the x, and then you add 3. So according to the transformation table, if I have minus 3, that would be to the right, right? So move to the right of 2 to the x, and the plus 3 would be up 3 of 2 to the x. So let's verify by going to the to decimal. So if you forget, sometimes you can do that. So y equal to 2 to the x. The same thing, but I want to do minus 3. Okay, in here. Oh no. I want to have the minus 3 in the denominator, in the exponent. What's going on? So be minus 3. Huh? How come it's not letting me to? Maybe I have to do like that, x minus 3. I don't know. So you can see that the graph originally was here, the blue one is 2 to the x. Now it moved to 3 over, right? So this was 0 and this was 0. And if I want to do y equal to, so let's just turn this off, 2 to the x, but plus 3. So you can see that it's moving up. So it is here. So it was 1, now it is 4. So 1, 2, 3. So this is how the transformation look like when you're doing a vertical and horizontal shift. We can do another question. So these are some of the toolkit functions. I don't know if you still remember them, but let's try to see if we can write the equation of that. By writing the equation, to do that, first you have to identify what kind of toolkit it is. It looks like a parabola, so the original function should be x squared, right? And then what happened is you see it is compared to x squared is like this. This is down 25. Is it down 25? So this function is, this equation is what? X squared minus 25 because it's down, so it's outside. So this function is the v-shaped function, which is absolute x, right? So we know this is part of the absolute, but you can see that it is moving to the right and then down 2. Move to the right, my function will become x minus 3. Down 2 is minus 2 outside. So this is the function, this is the equation of x. This corresponds to this because I know this is the v-shape at 0, 0. And I know that one is 0, 0. And what about this look? What about this? This look like a square root function. It used to be the parent function is like this, start from 0, 0. But this 0, 0 seems to be moved to left 3, right? And also, does it down 1 and down 1? So it must be corresponding to equation of this new function is left 3 is add, right? Down 1 is outside minus 1. So that's how you can write the equation. You look at the original function, you find out what has been done, and you can write the equation. The second thing we want to talk about for transformation is sometimes we have functions that are actually a reflection of the original function. And there's two ways to do reflection. You can reflect over the y-axis. This means horizontally. So originally it was on this side, and then you will reflect on here. Reflect on the y-axis is negative x. So you have a negative inside. So you reflect horizontally. Everything that you here become here, reflection. So x become negative x. If you look at your points on the new graph, your x become negative x. Reflect over x-axis is vertical reflection. So your whole thing over here become below negative of f of x. So y becomes negative y. Your x doesn't change, but your y changes. We also have two more called horizontal compression, horizontal stretch. That is when you multiply a number called a inside the function. That means instead of x, now you have ax. If a is greater than 1, x become x over a. It is a compression. You multiply by a big number, it become a compression. If a is like a fraction, it become a stretch actually. So it's kind of like opposite. So you can see that for horizontal transformation, everything is opposite. You multiply by a number, it's supposed to be bigger, but it's actually compressed. And oh, actually I forgot to type here. So x becomes x become x divided by a. You multiply by a, x become x divided by a. Vertical compression and vertical stretch is when you multiply an a outside of f of x. So if it's a big number, then it's a stretch. If it's a small number, it's a fraction. It become a compression. So and y become a times y. So these are the 4 more transformation. Let's see how to do this first. Do a quick sketch of square root of negative x. You see how we have negative inside, right? Inside. So that is reflect over the y-axis, left and right reflection. So it would be like this because I know square root x is like that, right? So you reflect it over that side. Do you still remember this must be a reflection of x cubed, but it's outside of x cubed. So it is a up and down reflection. So we know x cubed's graph is like S, like that. So up and down. So this part become on the bottom. And then, so we would say instead of going up like this, I go down like this. And in this part, supposed to go here, but it will reflect on this side, so this is negative x cubed. They reflect up and down. So that's how we sketch it. And then if I have f of 2x, what do you think? Inside is horizontal compression. If you multiply by a number, compress, it is always 1 over that. Compression of 1/2. Compressed to 1/2 horizontally. Your x become 1/2 of x. F of negative x is reflect over the horizontal, reflect over the y-axis, so left and right. Negative 2 is an outside, so you would have two things. One is reflect vertically over the x-axis, and then you multiply by 2, that is a vertical stretch, because 2 means multiply by 2, so y is 2y, negative 2y, because there's a reflection. Okay, so just like before, we want to write a formula. If it is x cubed and I shift up and left 2, do you know how to do? So it is just left and right. So shifts up, so be x cubed plus 6, but left 2, I have to change the inside, become a new function g of x is equal to left is adding 2, it's cubed, and then up 6, right, up outside. 1 over x squared is reflect over the x-axis, so reflection over the x-axis is up and down, right, because x-axis is up and down. This is x-axis, so up and down is vertical, so it is negative 1 over x squared. And then it is a vertical stretch by 2, so just multiply by 2. So the new function is negative 2 over x squared. That's it. 3 point. Yeah, we will do a combined transformation in the next video.